A major hospital network hires your engineering team to build a custom management system. The instinct for a junior developer is to walk into the hospital, find the manager, and simply ask, "What kind of software do you want us to build?" That approach practically guarantees failure. Customers routinely forget critical details of their daily workflow. They lack the technical vocabulary to describe system architecture, and they rarely know what is actually possible to build. If the hospital manager forgets to explicitly request an online payment portal during that initial meeting, the developer simply leaves it out of the code. Half a year later, the deployed software is entirely missing the payment feature. Adding a core financial module now requires engineers to tear down the database architecture and rewrite thousands of lines of code. The budget inflates and the timeline collapses. Professional engineering teams bypass these late-stage overhauls entirely by executing a proactive, systematic investigation before a single line of code is written. A software failure rarely originates in the compiler. It begins in the failure to extract an accurate blueprint from the human mind. To elicit means to actively draw out hidden or unstated information from a subject. In software engineering, requirement elicitation is the formal process of collecting, discovering, and understanding the precise needs and business processes of the customer. The targets of this process are the stakeholders, defined as any individual who will interact with or be affected by the final software. For a hospital, this network is vast: administrators, doctors, patients, and receptionists. A critical mistake is narrowing focus to only the highest-ranking stakeholder. An administrator cannot describe emergency triage workflows. Relying on one perspective guarantees doctors' and patients' needs are ignored. A finished software system is only as robust as the completeness of its initial stakeholder map. Missing a user means missing a requirement. To map these requirements accurately, engineers deploy a specific suite of extraction techniques. The most direct approach is the interview. By sitting down with a stakeholder one-on-one, developers can drill down into the details. If a customer mentions an online payment portal, the engineer can immediately ask the logical follow-up: should the system generate digital payment receipts? While this yields highly detailed data, interviews consume massive amounts of engineering hours. They become mathematically impossible to execute when your software targets 10,000 users. When users cannot articulate their own workflow, engineers shift to observation. Consider building a point-of-sale system for a supermarket. Instead of asking a cashier to list every action they take, the engineer silently watches the actual process, scanning barcodes, generating the bill, processing the payment, and printing the receipt. This passive analysis uncovers hidden microsteps, like applying a split payment or overriding a scanned price. Actions so routine that a cashier might easily forget to mention them during an interview. However, observation is inherently slow. Furthermore, subjects often artificially alter their behavior when they know an engineer is watching them work. These high-touch methods produce the highest fidelity requirement data, but their application is heavily constrained by the limits of human time. To solve the problem of volume, engineering teams rely on the questionnaire. By replacing the intimacy of a one-on-one interview with a standardized digital survey, developers can extract data from thousands of users simultaneously. This method is cheap and incredibly fast, but it sacrifices nuance. Users frequently skip complex questions, leaving engineers to aggregate broad metrics rather than deep operational logic. When the problem requires unprecedented features rather than standard workflows, teams move to brainstorming. This involves gathering diverse stakeholders, developers, customers, managers, testers, and designers, into a single room where no proposed idea is immediately rejected. Forcing these different disciplines to physically collide generates creative, lateral solutions that a single perspective would never reach. The inherent risk is structure. Without strict moderation, brainstorming sessions devolve into unorganized tangents, or dominant personalities take over and silence the rest of the group. Volume and creativity are powerful extraction tools, but they yield raw information. That raw data requires rigid frameworks to become actionable engineering specifications. Frequently, a customer will admit that they have no idea what they want until they actually see it on a screen. This triggers the prototyping technique. Engineers build a basic interactive sample interface. When the customer clicks through this rough draft, they react to the layout and functionality, actively generating solid requirements through their direct feedback. This guarantees high customer satisfaction and extreme clarity, but building that initial draft incurs extra upfront costs and delays the actual development timeline. Finally, when an engineering firm is hired to upgrade an existing legacy system, they employ document analysis. Rather than starting from scratch, developers extract the core logic by auditing user manuals, the old codebase, documented business rules, and historical performance reports. It is an efficient way to baseline the project, but it carries a specific danger. Engineers risk blindly copying outdated business rules and hard-coding past mistakes into the brand-new architecture. Sometimes the fastest way to map future software is to excavate the past by dissecting legacy code or building a tangible rough draft. Professional software engineers do not guess which of these 6 techniques to deploy. They run the variables of the project through a strict decision matrix. They weigh total users against budget, technical fluency, and timeline constraints. If serving 10,000 users globally, the matrix outputs a questionnaire for scale. If core functionality is entirely unclear, it outputs a prototype to force actionable feedback. It mirrors the logic of opening a new restaurant. You don't guess what the neighborhood wants to eat. You walk to tables to ask diners directly, an interview. You leave feedback cards by the door, a questionnaire. You watch which dishes are left half-eaten, an observation. And you test new menu ideas by handing out free sample plates, a prototype. Executing this phase with precision secures the ultimate payoff. It eliminates the misunderstandings that lead to catastrophic mid-development architecture redesigns. Once gathered, every data point from these techniques is synthesized into the software requirement specification, the master architectural blueprint that governs the entire project. Requirement elicitation stands as the foundational algorithm of software engineering. It proves that a system must first be deeply understood in the real world before it can ever be built in code.